Hello guys, welcome back to MedZone African Motives. We are still on our mathematics for grade 11, and this is an exercise that we are going to be focusing on revising on our tangents. So in this platform, that is the major case that we're gonna have. As you know that, all right, we're just gonna need you to remember one of these things before we move on to this exercise of today. We are given keywords to remember on the previous exercise that we had. All right, opposite sides, AD and B and BC are opposite sides, no common vertex. Okay, adjacent sides, AD and DC are adjacent sides, common vertex if they are adjacent. So that is the concept that you are given. If you are given AD, all right, and BC, these ones, this BC and AD, they are opposite sides. They do not have any common vertex. They do not meet at any point. That is what you're trying to say. But if you check AD and DC, they are going to meet at a certain point. They are adjacent sides. Adjacent sides, they have a common vertex, all right? So that is the case that you're going to have. Then also in this case, opposite angles B and D are opposite, all right, opposite angles, which is angle B and D. These ones, they are referred to as opposite angles. Supplementary line, that is a fourth line, a supplementary, a symmetry line. Guys, you see what I'm thinking of? I'm always on the angles because of this part that I was thinking there. So if you're given a symmetry line, there's a line that is gonna divide whatever shape that you're given. If let's say we are given triangle ABC like this, then this is the line of symmetry. The line of symmetry is going to divide your shape into two equal parts, meaning to say this triangle, it's a half, and this is another half that you're given. That is a fourth line. All right, so that is what you need to remember, that you need to know. Then also to prove a cyclic quadrilateral, I talked about this. Also, just make sure that you remember this. Always remember that. Remember it. It's very, very important that you remember that. All right, let us go through to our today's exercise. O is the center of the circle in each fig that we are given. So you're given these diagrams. All right. In each case, determine the values of A, B, C. Clearly state the reasons. A, B, C, but I don't see A, B, C. All right, here I've got A, B, C on this part. But in this case, they needed us to determine all these angles, not A, B, C. Like, okay, they're like in so on and so on and so on. This is all right, A, B, C, D, and so on, guys. You see the way that they're asking now, it's confusing us. All right, so it's gonna be A, B, C, D up to Z, whatever that you have on your diagram. The first case that you're given is this one of the tangents. So the idea of the tangents is going to be like this. Remember from your theorem number 6 that you were saying that if you are given two tangents that are being drawn from a circle to a circle, they are being drawn from a circle from the same point outside of the circle. They are equal in length as long they are from the same point to the circle. These two tangents, they are going to be equal. If this is P and this is R and this is Q, it follows that PR is going to be equal to QR or RQ. Two tangents, they are drawn to the circle from the same point. From the same point, they are drawn to the circle from the same point there. They are going to be equal in length. And also, if you have got the same scenario of a tangent, then it's drawn like this, then we've got a chord. Remember our theorem 7 also that it states that if I have got a tangent like this, then an angle is drawn in between a chord and a tangent like this. In between a chord and a tangent, this angle is going to be equal to the angle in the opposite or in the alternate segment. The angle between a tangent to the circle and the chord is equal to the angle in the alternate segment. So meaning to say also that the angle that we have at this point here is the same as this angle here. This is all about your tangents that you need to know and so forth. And all other theorems. It does not mean that when you're just focusing, when you have a tangent, you just have to focus on a tangent. No, you have to also think of other theorems that we did, that we have in our syllabus. All right, let us consider the first part of our question. On diagram number 1, this is what we have. As you can see, I've got tangent BC. B is a tangent. EAB is also a tangent. We can also make adjustments to calculate whatever that we want. In this case, we have got O to A as the radius, and also O to C like this. It is also a radius. Remember, there is a W there at C. So it depends with which angle that you want to calculate in the first place. But as we can see, that is what you have. All right. In this case, I want us to see that we can calculate, or we can have the angle, this one at C, the angle at C from the radius concept, or O to A like this. From point O to A, it's a radius. From O to C, it's also a radius. So we know that these two are equal. So OA is equal to OC. That is the radius concept. So meaning to say these opposite angles are equal. I'm just going to call this C1, and I'm just going to call this C2. Yes, this is W, the whole of this. So meaning to say, according to my sketch, C1 is going to be equal to 31 degrees, which is equal to the angle A, meaning to say I'm referring to this OCA. Okay, let me just write it that way. Maybe you might understand me. OCA, angle OCA is going to be 31. So that means we can calculate the angle O, which is AOC. To calculate angle AOC, this is what you're going to need. Angle AOC is inside of the triangle, and this angle is 31 degrees. And we understand that angles inside of a triangle, they add up to 180 degrees. So from that concept, that angles inside of a triangle, they add up to 180 degrees. So if we subtract these two angles, the 31 degrees and the 31 degrees, these two, from 180 degrees, we are going to obtain angle AOC. 31 plus 31, that is 62. And if we subtract 180 minus 62, that was going to give us 118 degrees. So meaning to say this is 118 degrees, the angle O. So there are so many things that you can answer, whatever that you want from the angle, or you can calculate the angle U in this case. Guys, it's up to you the way that you want to figure it out. I do not know what you want to, how or are you going to have it, but this is a basic part that you're going to have. All right, so we are going to see that angle U was going to be equal to, remember that if I have got a chord like this one, AC, it's a chord, it's creating an angle at F. The same AC is creating the angle at O, and we understand that the angle at the center is twice the angle that is going to be at the circumference, as long as it is created from the same chord. So U is the angle at the circumference, so it's going to be 118 degrees divided by what? Divided by 2, which is going to be 59 degrees. So this is the angle from the angle at the center concept, the angle at the center, the angle at the center concept. All right, gonna see that this will be at the circumference, it's a half from that one of at the circumference. So this was gonna be 59 degrees. So if this angle is 59 degrees, it also follows that, in fact, angle T, we could have calculated angle T, because there OA and OB, it's a radius concept there. OA and AB, they meet at 90 degrees. All right, so OA is perpendicular to AB. So meaning to say OAB is 90 degrees. That's angle OAB is equal to 90 degrees. So if angle OAB, this one, is 90 degrees, what does it mean? It means I can calculate the angle T, because this one is 31 degrees, the angle A there. So it means angle T is going to be 90 minus 31. That is angle T, 90 degrees minus 31 degrees. So if we are to subtract this, we're going to get the same answer of 59 degrees, which is the same concept that we could have taken angle between a tangent and a chord. So the reasons are the one that I'm explaining as I'm saying, as I'm talking right now. All right, so we could have taken this angle T, the angle between a tangent and a chord. Remember I said angle between a tangent and a chord is equal to angle in the alternate segment. So angle T is equal to angle U, which is equal to 59. So it depends with which angle that you calculated first. maybe you calculated T first. It means U was not going to be this way. U was going to be that concept of angle between what? A tangent and a chord equal to the angle in the opposite segment. That could be the reason. So it depends with which part. Guys, this is geometry. You answer the way that you understand, all right? As long as you understand the concept, it's very, very fine. Remember, we talked of the tangents also that are being drawn from the circumference, from the same point to the circumference of a circle. They are drawn from point B to the circumference at C and also at A. So it follows that AB is going to be equal to BC. These two lines, they are equal in length. Remember, I explained that. So if they are equal, it also follows that the angles that are opposite to these sides, this side, it is opposite to angle T, and this side is opposite to angle Y. So it means the angle T is going to be equal to the angle Y. So this is also 59 degrees. So we can also refer to angle Y equal to what? Angle Y equal to 59 degrees also. That's the angles opposite what? Angles opposite equal sides, which is opposite what? Equal sides. Angles equal or angles opposite equal sides. So these they are that is the concept. That's an isosceles triangle. You are formulating an isosceles triangle. This triangle that you are formulating here is going to be an isosceles triangle because these two sides are the same. These two angles, the base angles, they are supposed to be equal also. That is another way that you can also take it. We can also calculate the angle at Z. We can have this angle at Z. So many ways to calculate the angle at Z. Calculating angle Z, you can use the angles in a triangle. So you can consider angles in a triangle to calculate the angle Z. That is, angle Z is going to be 180 degrees minus the two angles inside of the triangle, the 59 and the 59 degrees. They are inside of the triangle ABC. So that is angles in a triangle, they add up to 180 degrees. All right. They add up to 180 degrees, add up to 180 degrees. So that is the idea there. So if these two angles, they add up to 180 degrees. If these three angles, they add up to 180, I'm going to subtract the two angles from 180 to obtain what? To obtain the third angle. So if I add these two angles, this was going to be 118, then I subtract 180 minus 118, this was going to be 62 degrees. So it means our angle Z was going to be given as a 62 degrees, this one. It was going to be a 62 degrees. All right, what are we left with? We need X. We need the W there. Remember where the W is. I'm just going to erase this so that we go back to our W so that you can originally see. Remember, this was a third one, which was part of our adjustments. So I'm just going to erase what I had before. All right. So what are we going to do to calculate these two remaining angles, the W and the X? All right, the angle X in this case, as you can see, it is an angle that is between a tangent and a chord. Remember what I explained? Angle between a tangent and a chord is equal to the angle in the opposite segment. If you hold the chord FC, it creates angle at A. That is the angle in the alternate segment, opposite segment. This one, it creates an angle at what? At A. So angle A is 31 and 27. If you add these two angles, you obtain angle X. So angle X is the angle between the tangent and the what? The tangent and the chord. So that was going to be the reason that you're going to use in that case. All right, so let us just remove this part and see what we are going to have. So like I said, our angle X was going to be 27 plus 31. So it was going to be 27 degrees plus 31 degrees, which is FAC, the whole of angle AFC. That is angle between a tangent. So this is angle between a tangent and a chord. A tangent and a chord. So it must be between a tangent and a chord is equal to the angle in the alternate segment. That is the angle in the alternate segment. That is the sum of these two angles that we are given. And that was going to give us a 58 degrees. So this is 58 degrees. X is going to be 58 degrees. So we have got X. Then what about W? Angles on a straight line. To find W, just going to consider angles that are found on a straight line. They add up to 180 degrees. It's also part of geometry to know that straight line angles on a straight line add up to 180 degrees. So W was going to be 180 minus these two angles, which are on a straight line, the 58 degrees and the 59 degrees. So there we are talking about angles on a straight line. So remember that angles on a straight line add up to 180. All right, they add up to 180 degrees. Whenever you have got angles that are found on a straight line, they are going to add up to 180 degrees. So that means we were going to have our W from this simplification. So it was going to be 180 minus 58 plus 59, which is 117 degrees. So if we subtract this from 180 degrees, that was going to be 63 degrees. So this angle here was going to be 63 degrees. There are so many ways that you can find these angles. I just hope with time we have to work or to do the same questions, but in different ways so that you see that, guys, there are so many ways. All right, I'm seeing that there's also a V that we almost left here. The V, also the V is applying the same concept, the angle between a tangent and a chord. So this will be equal to the angle in the opposite segment. So the chord AF, it creates the angle at what? It creates the angle at C. So the angle created at C is the same as the angle that is at V, the angle between a tangent and a chord. So meaning to say V was going to be equal to 63 degrees as well as what we had on W. So I explained that angle between a tangent and a chord. So that is the case that you're going to use. Number two, we are given again to calculate these sides, that the angles that you're given only an angle of 52 degrees, which is at P, this one. How can we answer our question? All right, let's see. According to this, we can see that the angle at A is going to be twice the angle at P. Remember that this is P, QR, our chord. It creates the angle at P. It is also creating the angle at the center. So the angle at the center, O is the center. So the angle at the center is twice angle at the circumference. So A is going to be 52 degrees times 2. Angle at the center is twice angle at the circumference. So if you multiply 52 by 2, that was going to be 104 degrees. All right, on angle B, we were going to see that the angle B is the angle between a tangent and a chord. So I say the angle between a tangent and a chord is equal to the angle that is formulated in the opposite segment by the chord QR. We are creating an angle in this segment at what? At P, which is 52 degrees. So it means if angle P is 52, also angle B was going to be 52 degrees. That is angle between a tangent and a chord is equal to angle in the alternate segment. So that is what we're going to have on angle B. All right, this part, remember, we have got angle B there. And also we calculated angle at A. Remember the angle at A, we said it's 104. All right, so let us consider again what we can calculate. If we are to consider this part clearly, we can also have this angle here because this is a radius concept. This one is a radius concept. This one from O to Q is a radius. O to Q is a radius. Then O to R is also a radius. OQ is a radius. OR is a radius. So meaning to say OR is equal to OQ. If they are equal, then it means the whole of this angle here is equal to the whole of this angle at D. So there they are saying this is E, this is also E. What does it mean? It means they are the same. This angle and this angle are the same. So this line is a line bisector. So how do you find the angle at D and this whole angle at what? At E, the whole part at E there. How do you calculate this? Because these two, they're equal, it also follows that these angles, they will be equal. The angles that are opposite equal sides. Angles equal opposite sides. So the angle OQ from O to Q to R, OQR is going to be equal to angle ORQ. And as you can see, angle ORQ is the one consisting of this E and this E. This is an indication that these two angles are the same. So how do we calculate either of these? OQR or ORQ. How are we going to calculate this? We simply subtract the 104, the angle that is inside of the triangle. Whatever that we get, we divide by 2 because they are equal, these angles. So to divide by 2 is to indicate that these two angles are equal. So 180 minus 104, that was going to be a 76. Then you divide this by 2, that was going to give us a 38 degrees. So this is going to be 38 degrees. So what it means is that OQR, which is D is going to be 76 degrees. And the whole of this angle, ORQ, is also 76 degrees. The whole of that angle that we are given there was going to be a 76 degrees in that consideration. All right, that's 180. Guys, did we I didn't divide by 2. Sorry for that. I did not divide. I divided by 38. Guys, where am I getting this? 70. That is 8. Where am I getting this? This is 38. Where am I getting this 76? Now I'm still looking on the 76. No, this is 38. Remember, we said 78. After dividing 76, divide by 2, that's a 38 degrees. All right. So it means angle D is equal to 38 degrees. From this, our angle D was going to be 38 degrees. We talked about this. And also angle E. How are we going to have angle E? That is the question now, because this is E, this is E. This is to show you that these two angles are equal. So angle E, it is simply going to be 38 divided by 2. So 38 divided by 2, it is going to be 19 degrees. Because the whole of this angle is 38. But there are two angles called E also. So to give us the same letter means that is the same angle, like they are equal, those two angles. That is what they are trying to say. So instead of them giving us that, okay, these two angles that they write like this, E and E, you are supposed to know that. All right. So I think that's it. All right. What else? What else do we need? All right. We're going to also need angle C. So angle C is 90 degrees. This one, remember, a radius and a tangent, they meet at 90 degrees. Or you can add this 52 plus 38 from 180 degrees. Still, it's another way, but this one, it's 90 degrees. A radius and a tangent, they meet at what? They meet at 90 degrees. A radius and a tangent, they meet at 90 degrees. So meaning to say angle C was equal to 90 degrees. Angle C is equal to 90 degrees. There is just a theorem that you use. All right. What else are we left with? There is angle F here. There is angle F there. If you check there, there is angle F. And how are we gonna have this angle F? If we were to consider properly, we can consider angles in a triangle to find angle F. Remember angle E, when we divided this by 2, we said angle E is 19 degrees. So this angle at E is gonna be 19 degrees, the same as this one is gonna be 19 degrees. So if this angle E is 19 degrees, we can find angle F. How are we going to find angle F using angles in a triangle concept? So angle F was going to be 180 degrees. minus the angles in a triangle. There is P, which is 52 degrees, plus there is D also inside of the triangle. Using triangle PQR, I'm going to take triangle PQR. All right. There is 52, there is 38. There's also E inside of this triangle. E is also part of this triangle, which is 19 degrees. So you are going to subtract these angles from what? From 180 degrees. So these, the sum of these angles is 109. So this was going to give you 109 degrees, and 180 minus 109 is 71. So it means F was going to be equal to 71 degrees. So that is our angle F at the end. All right, our angle F here was going to be 71 degrees. Okay. Then what can we do to find angle G? So angle G is equal to angle Q, VR, vertically opposite angles. This one G, these are vertically opposite angles. All right. So you can also calculate angle G. Angle G is equal to angle Q, VR. It is equal to angle Q, VR, which is vertically opposite angle. So these are vertically opposite angles. So why are we focusing on QVR? Because we can calculate QVR from angles in a triangle. QVR, angles in a triangle, they add up to 180. So you're going to subtract angles that are in this triangle Q to V to R like this. This triangle QVR, this one. So angles in a triangle there, we are going to subtract this angle D inside of the triangle, which is 38 degrees. There is also angle E inside of the triangle, which is 19 degrees. These are the two angles that are inside of this triangle. So we are going to subtract these two angles. That is going to be, the sum is 57. And if we subtract this from 180 degrees, you're going to obtain 123 degrees. So that's your angle G from the vertically opposite angles. So that was the idea there. All right, so I think we have answered everything there. Okay, just look how ugly the diagram is, guys, now. Anyways, that is how your exam is going to be like. So in order for you to understand, know your theorems, because it's going to be so much ugly. So it's going to be so much ugly, like more than this, under exam condition. So you try by all means to color up your diagram, know your theorems. That is the best way, no matter how much messed up your diagram is going to be. If you know your theorems, it can be best. All right. Another question again, we need to calculate these angles. We've got a tangent that is being drawn on the circle. Remember, we said a tangent is being drawn and there is a chord. That means the angle at X is going to be equal to 50 degrees. Angle between a tangent and a chord is equal to the angle in the opposite segment or in the alternate segment, which is the angle at X. So the angle at X and this angle at 50 are the same. All right, so X was going to be 50 degrees. All right, so X there was going to be 50 degrees. Also, we can calculate the angle Y in this case. Angles in a triangle, they add up to 180 degrees. So Y is going to be 180 minus the two angles inside of the triangle, the 70 and the 50. Remember, we stated that this angle is 50 degrees. So 70, plus 50 degrees, that is something like 120 degrees, and 180 minus 120 is going to give us 60 degrees. That means the angle Y is going to be 60 degrees. Also, we can calculate angle W. Y, angles on a straight line, they add up to 180 degrees. I talked about that. So meaning to say angle W from the angles on a straight line, again, we can calculate that angle. Angles on a straight line, they add up to 180 degrees. So meaning to say the angle of 50 degrees, the angle of 60 degrees, the angle W together, they sum up to 180 degrees. So I'm going to remove the other two angles that are on this straight line. Still, I'm going to have the same answer with any other theorem that could have been used. 60 plus 50, that is 110 degrees, and 180 minus 110 is going to be a 70 degrees. So meaning to say angle W was going to be equal to 70 degrees angles on a straight line. All right, so that is going to be your reason, the angles on a straight line. What about angle Z? If we are to consider PQRS, this one is a cyclic quadrilateral. All the four vertices are on the circumference of a circle. All the four angles, they are on the circumference of a circle. So it means the angle Z in this case, if we understand the concept of a cyclic quadrilateral, it follows that opposite angles of a cyclic quadrilateral are supplementary. So it follows that angle Z was going to be 180 degrees minus 60 degrees at Y, because these two angles, they add up to 180 degrees. If you add angle Y plus angle Z, you must get 180 degrees. These are opposite angles of what? Of a cyclic quad. Opposite angles of a cyclic quadrilateral. They add up to 180 degrees. So that means we were going to obtain our angle Z in that case. 180 minus 60, that is going to be 120 degrees. So this is Euclidean geometry for you. You need to know your theorems. You need to understand the basics of your theorems. More questions like this are going to come from Meson African motifs. Till we meet again.